If you had asked an environmental expert in the West about waste management in China 20 years ago, the response would likely have been something along the lines of mountains of landfills, foul-smelling outskirts of cities, or an unsolvable waste crisis. Back then, there was a common belief in the global environmental community that China's rapid urbanization would eventually collapse under the weight of its waste problem. But fast forward 20 years and a set of astonishing statistics has completely overturned this perception. China now accounts for over 60% of the global waste incineration capacity, operating more than 1,000 modern incineration plants with a daily processing capacity exceeding 1.16 million tons of waste. This is more than the combined capacity of the US, Japan, and Europe. Of the new incineration plants being built globally, 7 out of 10 are using Chinese core technologies. Even Europe, once the global benchmark for environmental protection, has started importing complete waste incineration solutions from China. Several Central and Eastern European countries have handed their major waste management projects over to Chinese companies. Today, we will break down this often misunderstood industry. We'll explore how China's waste incineration sector moved from being blocked by Western technology and high costs to becoming a global leader in waste treatment, even exporting its technologies back to Europe, the birthplace of incineration. We'll dive into the struggles of this journey, the differences between China and Western countries, the economic impact, and most importantly, the 6 groundbreaking technologies developed in China that are now reshaping the global waste treatment landscape. The difficult beginnings of China's waste incineration journey. Many people don't realize just how challenging the path was for China's waste incineration industry. In the 1990s and early 2000s, China faced a double dilemma. Rapid urbanization was pushing millions of people into cities, leading to a 10% annual increase in municipal waste. At that time, over 90% of waste was disposed of by simple landfilling. In megacities like Beijing, Shanghai, and Guangzhou, the landfills were nearly full, and the cities were surrounded by mountains of trash that emitted foul odors and polluted groundwater. Waste siege became one of the biggest challenges facing urbanization in China. Landfilling was no longer a viable option. The only alternative left was incineration. But China had no mature incineration technology at the time. All core equipment, processes, and designs were controlled by Western and Japanese companies. To make matters worse, Western incineration technologies were fundamentally unsuitable for China's waste. Western technologies were designed for highly sorted, low moisture, high heat value waste. But China's waste was different. Due to the Chinese diet, over 60% of the waste consisted of wet organic waste, and the overall moisture content was as high as 55%, negative 65%. This meant the heat value was only half or a third of that in Western waste, referred to as wet waste or rotten waste in the industry. Imported Western grate furnaces, when faced with China's mixed waste, simply couldn't burn it efficiently. They required constant diesel fuel to maintain furnace temperature. Burning 1 ton of waste with diesel fuel alone cost over 30 yuan. And with high import fees and operating costs, the total cost of processing 1 ton of waste reached over 150 yuan. This was an unprofitable venture, barely sustained by government subsidies. Even worse was the bottleneck dilemma. If key parts broke, China had to wait for foreign engineers to fix them. Every day of downtime cost hundreds of thousands of yuan. Foreign suppliers refused to modify their designs to suit China's waste characteristics, claiming that their technologies were the global standard. In short, China had no technology, no experience, no bargaining power, facing both an urgent waste crisis and a Western monopoly on technology. The only path left was innovation. China's waste incineration today, a global power. Fast forward to today, and China's waste incineration industry has completely transformed. By the end of 2024, China will have over 1,000 incineration plants in operation, processing more than 1.16 million tons of waste daily, making up 78.9% of the total urban waste disposal in the country. Incineration has become the dominant method of waste treatment in Chinese cities. In comparison, Japan, which has one of the highest rates of waste incineration penetration in the world, operates around 1,100 incineration plants, but with a daily processing capacity of only 150,000 tons, less than an eighth of China's capacity. Even in Europe, the overall incineration rate is around 30%, with countries like Denmark and Germany, global leaders in the sector, still managing only 40% negative, 50% incineration rates. The U.S. operates fewer than 70 plants with a daily processing capacity of under 100,000 tons. And landfilling remains the dominant waste disposal method due to abundant land. China's environmental standards for waste incineration have also caught up with global leaders. The National Air Pollution Control Standards for waste incineration are now aligned with EU 2010 standards, including dioxin limits, which match those of the EU, Japan, and the US. In fact, local standards in cities like Beijing and Shanghai are often even stricter than the European baseline. In terms of enforcement, China leads the world in real-time monitoring of air pollution from incineration plants. All of China's waste incineration plants are connected to provincial environmental authorities, providing 24/7 live data. This level of oversight and rapid response to violations is unparalleled. However, there are still challenges. China lags behind in areas like waste sorting, fine-tuned operational efficiency, and creating a fully integrated circular economy system. European and Japanese incineration plants are near 100% integrated with district heating systems, and their energy recovery rates exceed 80%, with some reaching 90%. In China, only 30% of incineration plants use combined heat and power (CHP) systems, with the rest focusing on power generation. The economic benefits of China's technological breakthroughs. The economic impact of China's breakthroughs in waste incineration technology is clear. 20 years ago, using imported equipment to handle China's mixed waste meant low power generation and high fuel costs. Today, China's self-developed medium-temperature, high-pressure incineration boilers generate 280 to 400 kilowatt-hours per ton of waste, doubling the power generation efficiency. In total, by 2024, China's incineration plants will process over 400 million tons of waste annually, generating over 120 billion kilowatt-hours of electricity equivalent to the output of 1.5 Three Gorges dams, enough to power 120 million Chinese households for a year. This saves 9 million tons of coal and reduces CO2 emissions by 240 million tons annually, both significant environmental and economic benefits. Costs have also dropped significantly. The cost of building a plant with domestic equipment is now about 30% negative, 50% lower than the cost of Western plants. Operation costs have fallen as well. What once cost over 150 yuan per ton of waste to treat has now been reduced to 60 to 80 yuan. And this includes no additional fuel. Many of China's mature plants are now profitable on electricity sales and resource recovery alone, without relying on government subsidies. 6 key innovations driving China's leadership. China's success is rooted in 6 core technologies, which address the unique challenges posed by high-moisture mixed waste and have led to global breakthroughs. Innovative grate furnace technology. The mechanical grate furnace, developed in China, is designed specifically for high-moisture mixed waste. This technology adopts a composite structure of reverse push plus forward push grates, as well as multi-level inclined reciprocating wave grates, ensuring waste is evenly stirred and dried. The combustion process is divided into 3 stages: pre-drying, stage combustion, and cooling, allowing for stable combustion at 850 degrees Celsius, meeting stringent dioxin decomposition requirements. This technology achieves a 98% waste burnout rate, far exceeding the 65% negative 82% burnout rate of imported equipment, and offers a 40% negative 50% reduction in equipment costs. Multi-pollutant control and ultra-low emission technology. In response to China's high levels of chlorine, sulfur, and nitrogen in waste, engineers have developed a multi-stage pollution control system. This includes SNCR denitrification, rotary spray semi-dry desulfurization, activated carbon injection, bag filters, wet desulfurization, low-temperature SCR denitrification, and flue gas de-white technology. This 7-stage process significantly reduces pollutants. The core pollutants, such as dioxins, are reduced to 1/10 of the EU standard, reaching levels unmatched globally. Leachate treatment technology. China has pioneered 2 global leading technologies for treating leachate, which has historically been a major problem in incineration. The first system uses anaerobic fermentation combined with a 2-stage AO+ MBR membrane bioreactor, followed by nanofiltration and reverse osmosis, achieving a 99.8% COD removal rate. This system reduces treatment costs by 40% compared to Western technologies. The second system employs advanced oxidation, MVR mechanical vapor recompression evaporation, and quality separation crystallization, effectively treating leachate and recovering valuable salts like sodium chloride and potassium chloride. Fly ash and bottom ash resource utilization. Fly ash, a hazardous byproduct of incineration, has been a major challenge due to its high chlorine content and the presence of heavy metals. China has developed a fly ash desalting and resource utilization system that uses a 3-stage countercurrent washing process to remove salts. The treated fly ash can be safely co-disposed in cement kilns or turned into high-value materials like ceramsite and microcrystalline glass. The desalted fly ash can also be used in road construction, further reducing landfill requirements by 90%. Intelligent and digital control technology. China has implemented AI-driven precise combustion control systems. Using hundreds of sensors, real-time data such as flame temperature, furnace pressure, and gas composition are collected, and AI models adjust parameters like feed rate, grate speed, and air supply. This reduces nitrogen oxide emissions by over 20%, lowers material consumption by 10%, -15%, and increases automated operation rates to over 98%. The country also leads the world in implementing a digital twin system for incineration plants, providing real-time monitoring and predictive maintenance. Efficient heat recovery and co-disposal technology. China has developed a high-efficiency waste incineration boiler capable of handling high-temperature and high-pressure steam, boosting power generation by over 40%. In co-disposal, China has pioneered a system that allows various types of waste, such as food waste, sewage sludge, and industrial waste to be incinerated together, improving land use efficiency by over 60% and significantly reducing regional waste disposal costs. China's global influence in future directions. 20 years ago, China was dependent on importing incineration equipment and technology, facing high costs and limited influence. Today, it has become the world's largest exporter of waste incineration technology, with over 100 overseas projects in Southeast Asia, Central Asia, and Africa. Chinese technology is also gaining traction in Eastern Europe, with countries like Serbia, Hungary, and Poland adopting Chinese solutions for major waste incineration projects. China's experience offers a new model for developing countries facing similar urbanization challenges. While Western countries took a century to develop their waste management systems, China's rapid innovation has led to a more cost-effective, environmentally sustainable solution that can be applied globally. In conclusion, China's waste incineration industry proves that developing countries can innovate and lead in environmental protection without simply copying Western models. Through its unique technological breakthroughs, China has redefined the rules of the global waste incineration industry and is setting a new example for the world. If you want more updates on China's latest tech moves and the unique way China views its own technology, please like and subscribe.